All right, this is the third tutorial in a little series on using the KISS library. And we're leaving straight out from having our Hello World application running and trying to introduce the idea of testing an application. So testing an application is really a big deal. Making sure that software does the things that you think it will do creates a lot of confidence in that it's going to really work. That matters to you as a person trying to write the programs. It also matters very much to the other people that might want to actually use your programs to have some evidence that it's really going to do the things that it's supposed to do. So this general trend in software development is hugely important. It's part of what makes software that can solve complicated problems for us. Of course, we're not there yet, and so I just wanted to introduce a simple way to test things. Here we are back in the Hi program, and I'll say it's not done yet because it hasn't been tested. So I'll say this is the way a lot of beginning developers test it, and that is they write a program and then they click run and then check to see if the thing you see is the thing that you expect. Now, we did do that last time, and in fact it does say hello in this case, but that's the sort of test where a human, in this case the developer, has to intervene and inspect a particular window to validate that what they see there is actually what the program is expected to do. Now that seems perfectly good in such a trivial little bit of code, but when things get more complicated, that gets way out of hand. And so instead of waiting until we get something complicated to fix, let's just start at the beginning and introduce the idea of testing. So here's our little application using the KISS library, and now let me show you how I might introduce a small test. So here we'll just add a new method, void, and really it just has to start with the word test and then some name that explains what sort of thing we are testing. So how about test message, and like run and all other method names, really you want a combination of letters. The habit in Java is do this camel casing business where if it's a bit of a sentence, essentially the first letter of each word except for the beginning of it is capitalized. So test message is a better choice most of the time compared to, say, test message with the little m. It just becomes easy to read. That convention is called camel case, and it is the convention that Java adopts for essentially everything once you start looking at the APIs that are involved. So right now, in the slow and steady runs the race, let's just print out yet another message out here, testing 1, 2, 3, like that, and semicolon like that. So now this is just another print statement, much like the run, and if I hit go up here in the IDE, oh look, so now when I run the application, I see test message started right there, and I see the message that I asked it to print out right there, which is eventually just hitting the mic, right, to see that method, the test message method, was just invoked. And then afterwards, after saying started, it said it ended, and it ends very quickly because it didn't really do very much. And then after that, the run happens. So that's the general habit with the KISS setup, is if you have a test in mind, you should create a method called test and some descriptive word or words that explain what it is that you'd like to have tested there. And then check something. So now let's just check something that, say, we know is going to work out, and that's called an assert. So assert that 1 plus 1, oops, you're right, is actually equal to, and in Java you use double equals for comparing two values. So 1 plus 1 does in fact equal 2, so there's something that we'd like to validate is true. And so if I run that, we actually see nothing new in your messages that the thing just worked out. But then, of course, what happens if we ask for something to be true which is not actually true? So let's assert 1 plus 1 is equal to 42 instead, and to see what happens in that case. So now we run that test again, and look. suddenly we have a lot of red ink all over our output saying that something went wrong. And if you dig through this, down here there's a caused by line. And notice it says something about an assertion error. So as you write tests, tests tend to assert that certain things are supposed to be true. And if they turn out not to be true, then what you get is what's called an exception. And this is what exceptions look like in the output. And that exception should hopefully give you a clue as to what went wrong and where. So here we see that we get an assertion error, which hopefully clues you in that it has something to do with an assert somewhere. But the nice thing is it also actually tells you where it was at. So app.java on line 19. So if I click there, the IDE jumps to the exact line where the problem occurred. So in this case, it's sort of a silly problem because, of course, we just asked for it to check something that was certainly false to see if it were true. But let's see if we can do a little better. So now I'm going to get rid of the assert that failed. All right. And what happens in the KISS framework, what happens is pretty trivial, but again, the idea is to keep it simple. There are more complicated testing frameworks you will certainly eventually use if you're building more complicated software. But in KISS, you can create all the tests you like. It will, before it invokes run, it will invoke all of your tests. And so, of course, they all have to pass. If the first one that fails, well, that's the end of that current run of your application, and you have to figure out what's wrong and fix it. And you can think of it as sort of a video game that involves a text-driven video game where you're trying to write code that passes the tests that you actually challenge yourself to build. So in what's called test-driven development, really we shouldn't have really written anything in run. We should have first written, well, what kind of tests do we want it to pass, and then start worrying about how to write the code that might make it pass that test. So again, that idea is called test-driven development, and we've got it a little backwards here, but this is just the first introduction. So let's get rid of these few things, and now let's try to assert that we really get the output that we see down here. And what you'll see, and this is actually quite often true, that testing that something works can be more effort than the actual solving the problem itself, and some people view that as frustrating, but in the world of lots of complicated things working together, I will only say that that is life. And if you want to be a responsible developer of software, you just have to appreciate that nobody wants stuff that almost works, and it can take a bit of effort to test it. So in this case, I'd like to verify that the println execution below actually does, in fact, give the message hello. So what I'm going to do in this kind of trivial test case is create a setup where I tell the test setup what I expect it to do, then ask the program to run and validate that in fact that's what it gets. So this is how we'll do that. So out open, we'll call this message dot verify. So that's going to be the name of a local file, and in that file I want to put some content, and the content is really the message that I'm really expecting to see that will come out of hello world. So in this case, it's actually just recreating the message, so hello bang, like that with a semicolon. So I'll open the output file. I will generate the message that I want. Now that the file is open, that will put that message in that file, and then go ahead and close it. And the way I close it is without close, like that. So that first step is a little bit of a setup step where I am creating a little file called message.verify, and in that file will be really what I am expecting. And the easy thing in this case is to just put in there the thing that I'm expecting, which is that word, that hello. So I open it and then I close it, and now instead of opening it up in order to write more information to it, I'm going to open the same file that I just created and say, well, that's actually not what I want to see in future output. I want to verify that as I get more output from my program, it actually matches what's in that that message. So out verify, message verify, and now, well, so how do I make sure that run actually does that? Well, in the words of Java, I invoke the actual program or the actual method in this case. So I open up the file which I just created a moment before, which has the message I believe it should generate. And now I open it up as verification. I invoke the method that's supposed to create that output, and then out close again. So now the output, which is now being verified, will now run. And now if it works, so now I'll run this program. And notice, so test message started, test message ended. It didn't take very long, but it now just validated that run, in fact, created the message that I expected. And if it didn't, then I wouldn't have never gotten to the run program, and I wouldn't have never seen the actual hello. So this hello, the one inside of the test, you never see the output of that because it is just being matched by the verify. As every output that happens inside of run, it will be verified against this file. And if there's some mistake, then it will throw an error. So for example, if I had a misunderstanding of what message was supposed to be sent and what message was, so let's change this to just hi, say down below. So we were expecting in our test to see the word hello, but in fact we only print the message hi. And if I try to run that program instead, there's our runtime exception. This time the stack is quite a bit higher than our simple direct assertion failure. But let's see if we can unwind this a little bit. So there's an exception, there's a caused by, so there was an error. Here's where it happened, and it's sort of down in the guts of this kiss util thing, and then something about a print stream and sun and all this stuff. But finally, if you just keep on looking down and down and down and down, eventually you get to the actual thing that you wrote, and hopefully, if the other libraries are written correctly, then you should be looking at what things did you do perhaps that caused this. So if I look at this, in fact, it takes me exactly to the line of the print statement where that mistake happened. So let me change this and see if we get like two different messages. So suppose we wanted to see the words hello world, but on two separate lines. Like that, and then down here and said we println hello, just like we were expecting up above, but for some reason this was written in a future we do not know yet, and Mars, say. So this was actually written on a different planet, and the world that they are at is just different from our world. So, oh, and sorry, let's get rid of that extra message there. And that is a common mistake. You do have to worry that tests are as hard to write as writing the solutions to them, and you have to kind of make sure that your tests that you're writing actually match up to the ones that you're running. But right now there is an intentional error, so they both say hello, and then there's a hello Mars. And so if we run this again, still we have the error. And again, the first time the error starts to shoot back to the code that we've been writing is in this app.run. Click on that. Oh, look, not the first one because that actually matched up. But at the second line, the Mars didn't actually match that one. Now, who's right? Well, assuming that the testers were the ones that were ones that were trying to build everything first, that it was actually written as an example of what run was supposed to do. We can look at the test. We actually know which test was running because if we go up the top, we see which one and when it started. So test message started. So it was this test that failed. On what line of our code did it fail at? And now we look through this thing. Oh, look, it was supposed to apparently print out hello world. It did not verify that. And a way to repair that, of course, is to have it print out the right message. So world like that with the semicolon. Okay. So now we have it all corrected, I hope, and we verify again. Oh, what did we miss? Println. Message hello. Oh, look at that. And this is why we write tests. Notice in the test message, world is lowercase, and then in my run, world is uppercase, and those two are not the same things. And so for this to actually pass the test, well, I need to fix that. By the way, if you look up a little bit by the cos by, it actually tells you what byte offset, so every character is roughly a byte of data. So it's the 6th character that was wrong between when it was starting to compare the verification with the actual output. And notice, so we have 1, 2, 3, 4, 5, somewhere around 6, and it turns out it's that one. So let's see if we can get that right. So hello world, hit go. Oh, look at that. So now it runs the test, passes the test, and since all tests, the only one test that we have, got passed, then it actually runs the run application, and we do actually get our little console output that we expect and have tested to be output. This is a big deal for building software that's reliable. It is very important to think that testing it is just as important, as in fact is more important than the writing of it. If you build software that has not been well tested, well, it is not a very strong component to the modern world of software development. So the KISS libraries hopefully make that a convenient thing, and there's your first now tested Hello World app.